Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to our second episode of microcontroller lectures, especially for the international students at Electronics and Instrumentation Study Program Universitas Gadjah Mada under Department of Computer Science and Electronics. My name is Akvianto Eko Putra, and we will talk about the introduction to microcontroller, but especially for the series from microchips, which is PIC60F87 or maybe PIC60F887. So the focus of our discussion is PIC68877. So as you can see in this slide, we have several microcontroller PIC microcontroller product family, which is separate into 4 groups here from the 8-bit. Just as you know that the 8-bit is according to the width of the data bus. So this is popular ones, microcontrollers is 8-bit and then 16 bits. So 8-bit and 16-bit it's more popular in the world for the microcontrollers. Beside 8 bits and 16 bits, we have 32 bits and 16-bit digital signal controllers. For the PIC microcontroller product family from the microchip, for the 8-bit microcontrollers, there are PIC 10, 12, 14, 16, 17, and 18 series. And for the 16-bit microcontroller, there are 24F and 24H. And also PIC 32 for the 32-bit microcontrollers. Beside all this of the product family, microcontroller product family, we have what we have here is 16-bit digital signal controller, as known as DSPIC. There are two types of DSPIC till now from the microchip, DSPIC 30 and 33F. So this is the PIC microcontroller product family. Divided as the width of the data bus. So the F in the name, just like this, 24F or maybe 16F, indicate that the PIC uses flash memory. Remember that just I mentioned before in the previous lecture that flash memory is used to store our program, which is can be run with our microcontroller. So the F in the name indicates that the PIC uses flash memory and can be electrically erased. It's popular right now. But the letter C, maybe you can find the other PIC60N, maybe PIC60C. So the letter C in the name means that the program memory can only be erased using ultraviolet lights. Except for the PIC16C84, which is used EEPROM and also can be electrically erased. So in the next slide, you'll see that from the bottom one, the PIC 10 series and also 12, 16, 18 is 8-bit microcontroller, then 16-bit microcontroller, and then 32-bit microcontroller. So this is the scaling the PIC MCU and DSPIC DSG families. And this is more functionality. Yeah, going up is more functionality, going right is more performance. So the last one, the PIC32 is known as the microcontroller with full or many functionality and also the high performance. and also cost more than the maybe PIC10, PIC12, and so on. So this is just only illustration visualization of the microchip product, microcontroller from the microchip company. So let's see now the detail. Why is the PIC16F87x so popular? Because it's very cheap, and also it's easy to make the minimal series. Okay, with the minimal circuit, you can build many applications. Additional components needed are only a 5 volts source, a 20 megahertz crystal oscillator, and 2 units of 22 picofarad capacitors. So the crystal oscillator and also the capacitor is used to create the oscillator circuit. So what are the advantages of the PIC60F877A? The IC can be programmed many times, up to 10,000 times. Okay, so don't worry, you can experiment as you are, just repeat it, and for one application to the other application and so on. So you can experiment the microcontroller. But if you use the simulator software, just I will mention in the next slide, so you don't have to worry about the programmable feature like this. Okay, because you use simulator. But if you use the real chip instead, so you don't have to worry, because can be programmed many times, up to 10,000. Very good to process the developing design. But what is the drawbacks of this microcontroller? It doesn't have internal oscillator. So you have to prepare to build the oscillator circuit using these components. 20 megahertz crystal oscillator, and also 2 pieces of the 22 picofarad capacitor. Okay, so that's the drawback, is doesn't have internal oscillators. So you have to prepare for the external oscillators. So this is the core features of the PIC60F8077. High performance RESC CPU, RESC, RESC, just I mentioned in the last lectures. Only 35 single word instruction to learn. I mean assembly language, okay, not C language, only 35. All single cycle instruction, except for program branches, which are 2 cycles. The operating speed is 20 MHz clock input, 200 nanosecond instruction cycle. Up to 8 kilo by 14 words of flash program memory, and also up to 368 by 8 bytes of data memory, or RAM. And also this microcontroller have EEPROM with size of 256 by 8 bytes. The pinout is compatible to the PIC-C 73B, 74B, 76, and 77. It also have interrupt capability up to the 14 sources, power on reset, or POR, power up timer, and also oscillator startup timer, and also have a watchdog timer. I will talk about this later, but in the previous lecture I mentioned and discussed about this feature as a watchdog timer. Okay, so after the core features, we will take a look upon the peripheral features. That PIC F16F877 have 3 timers like this, as you can see in this slide. The first timer is 8-bit timer counter with 8-bit prescaler. The second timer is 16-bit timer or counter with prescaler. Can be incremented during sleep via external crystal or clock. And the last timer, or the third timer, is 8-bit timer or counter with 8-bit period register, pre-scaler, and also post-scaler. Besides of these three timers, the PIC16F87 have two capture compare PWM modules. The capture is 16-bit and the maximum resolution is 12.5 nanosecond. The compare unit is also 16-bit. The maximum resolution is 200 nanosecond. So you can compare the data in 16-bit width every 200 nanosecond. And the last one, the PWM maximum resolution is 10-bit. What is the PWM? I will explain later. The other is 10-bit. Just remember, 10-bit, not 8, not 4, but 10-bit multi-channel analog to digital converter. Okay, multi-channel using the multiplexer, and I will talk about it later. Beside this ADC or analog to digital converter, this microcontroller have a synchronous serial port with SPI and SQC, and also USART. Three type of serial communication: SPI, I2C, and universal synchronous asynchronous receiver transfer or USART with 9-bit address detection. Also have a parallel safe port 8-bit wide with external RD, WRNCS, and also brownout detection circuit. This is very important because we have to anticipate the brownout event. So this microcontroller have brownout detection circuit internally. Okay, this is the pin diagram of the PIC16F87. There are 40 pins. This pin number 1, and this is pin number 14, and the bottom is pin number 20 and also 21. Okay, so what we have here, we have the IO pin, the port A, the port B here, right here, the port C, the port D, and the port A. This is C, this is D. Where's the this is the port E. Okay, so this is the symbol of the pin diagram. We will talk about it later. And this is the architecture, internal architecture of the PICF 877. Just like take a look right now. This is the flash program memory, which you have to store your program to this unit, so the microcontroller can execute your program for some or an application, maybe an application, some application or one application. So this is the ALU, this is the register, this is the status register, and so on. So this is you can read and study it with the PIC16F877 data sheet. You can search from the Google PIC16F877 dataset, so you can study it in detail about this architecture. So this is the simplified of the internal block diagram. They have a 5-port I/O, general I/O, and also 3 timers that we mentioned before, and also 3 types of serial communication: SPI, I2C, and USART, and also there are no internal oscillator. I'm sorry, this wrong. The oscillator, yeah, and also have ADC, PWM, EEPROM, RAM, and so on. So I'll skip this because this block diagram is also the same right here for the sector. So what about the memory of PIC16F877? There are 3 types of memory. The first one is program memory. What is program memory? The program memory is memory that contains programs, your programs, for specific application, which is the result from the compiled program, and you have to upload it your compiled program, maybe from the C language, or maybe in the assembly language. So you have to compile the program, okay, and then upload it into the program memory so the microcontroller can run your program. Just remember that program counter executes the command stored in program memory one by one. Okay, that's the program memory. The second one is data memory. What is data memory? This is a type of RAM which contains special register as such special function register, just as we know as in the previous lecture, SFR and also GPR, general purpose register, and the data memory. Variables stored in the data memory are stored during the running of the program and will be deleted when the microcontroller is turned off, because this is for the temporary data. And the last one, okay, these two memories, program and data memory, have separate database, which makes access to each bus more easily. And the last one, the number 3, no number 1, the SEEPROM data, electrically erasable programmable read-only memory, which is memory that allows storing variable as a result of written program storage. But the difference is the program memory is to store the program itself, but the EEPROM is to store your data. But the difference between the data memory and EEPROM is according to the volatile and non-volatile features. Because if you store the program, store the data in the EEPROM after the PIC is turning off, the microcontroller is turning off, it's still there. The data is still there. It's safe although the PIC itself is turned off. So that's the EEPROM. Just we discussed about the EEPROM in the last lectures or the previous lectures. So program memory and data memory are the memory needed to create programs, and EEPROM data is used to store data after the microcontroller is turned off. Okay, so what about the data memory RAM PIC16F87x? This is the storage media for variables. It's commonly known as a file registers and consists of two components. Just remember. The first one is GPR file, general purpose register file, same as RAM, and the second one is special purpose register file, same as SFR on the 1851 microcontroller. The address range is from the 0 to 511, because there are 512 total the location of the memory, and partition into 4 banks, and each bank extends to 7F or 128 bytes. Users can only access one RAM button or bank in one of the 4 memory bank and only one bank at a time. The default bank is 0, number 0. You can access the register at another bank, but it must be done through a program. There is a special register that can be accessed from all bank goods, for example, the status register. So that's the data memory or RAM of our microcontroller. So what about the register? Some register is I mentioned this in this slide. WREG working register, the PC is program counter, FSR file selection register, IDF is indirect through FSR. This register is for the addressing mode, but you don't have to worry, because we will write the code, write the program in the C language, not in the assembly language. The other is PCL. This is program counter low byte, and PC LED, program counter LEDs. Memory map register is status port entries. Okay, the port register is used to read and write the data from inside to outside and from outside to inside. Okay, outside microcontroller to inside the microcontroller. That is the read, the read operation. But if we write into the port register, it means that you send the data from microcontroller to the out of microcontrollers. So, do we have to configure first? Yes, of course. You have to configure the trace register. There are 5 in this PIC60F87x. Trace A, trace B, trace C, trace D, and trace E. Each is according to the port A, port B, port C, port D, and port E. Okay, so this is the register to configure the data direction. Okay, I will show you later. Okay, and also we have a status register. So this is the WREC register. This is a 8-bit register. It's used for arithmetic and logic operation. Used in many instructions, include the source of can be used as the source of the operand, and also the destination as the result of the instruction being executed. The other one is program counter register. Program counter register is 30 bits in size and is able to handle 8 kilobyte by 14-bit program memory space. This PC keeps track of the program execution by holding the address of the current instruction. It is automatically incremented to the next instruction during the current instruction execution. So, beside the program counter, we have a program counter stack. This is program counter stack, or PCS, is an independent 8-level stack. Is used for the program counter. As the PC is 30-bit, the stack is organized to 8 by 13-bit register because 8 level is only 8 level. Okay. When interrupt occur, the PC is pushed. The value of the PC, is pushed onto the stack. When the interrupt is being served, the other interrupts remain disabled. Hence, the other 7 register of the stack can be used for subroutine calls within an interrupt service routine or within the mainline program. Okay, this function of the program counter stack. The other register is FSR register as INDF register. So the file selection register is used to data memory address pointer is 8-bit register and also used in the indirect address sync mode. So the INDF register is indirect through FSR, address 0 and 80 hexa. INDF is not a physical register. Accessing INDF is actually access the location pointed to by FSR in indirect addressing mode. So this two is relate the FSR and INDF registers. The other is the PCL register, is program counter low. Actually lower 8 bits of the 13-bit program counter, both readable and writable. And the other is PCLET register for LEDs, 8-bit register which can be used to decide the upper 5-bit of the PC and etc. So what we have here is from the WREC register, okay, PC, PCS, FSR, INDF, PCL, and also PCLET register. So this is the status register. Status register is 8-bit register that stores the status of the processor. In most cases, the register is used to switch between the banks. So what we have here, we have 8 bits. The first bit is used to indicate which when the arithmetic operation have a carry or borrow, and the other is the second bit is digit carry, the third bit is 0 bit, the other is power down, timer out, RP1, RP0 is register bank select, and register bank select bit is IRP. Okay, so this is the status register, and we continue to the peripheral features. We have a 6 slide here. Just you know that PIC60F87 has 5 I/O port, 5. Okay, yeah, A, B, C, D, E. But only B, C, and D have 8-bit wide bidirectional. A has 6-bit, and E is only 3-bit wide. Now, just I mentioned before that each port has a 2 control register. There is S and port. Most pins have a 25 milliampere sourcing, thus it can drive LEDs directly. Please note that these pins can drive LEDs directly. Okay, it can source and also it can sync. So this is the resume of the port. Okay, A, B, C, D, E, the number of iOS 6, 8, 8, 8, and 3. The port E is also have alternate of ADC input. The port B has alternative of external interrupt inputs. The port C is for serial port and also timer I/O. The D is parallel slave ports, and the E is AD converter input, just like port A. Total I/O pins 33 for 40 pins of the PIC16F87 pins. So, what about the ADC? The ADC is only available in 40-bit and 16-bit cores. I think it's 10-bit, not this kind. The result, okay, the result is 10-bit digital, okay. Okay, this is, we have 8 channels multiplex. And also we have a timer, just I mentioned here. Timer 0, timer 1, timer 2. First, second, and third timer. And what we have here is serial communication. We have UART, can do from 300 bps to 115 kilo bps. Yeah, and also we have SPI, serial peripheral interface, and I2C. I will explain in the separate slide or separate lectures. And the last is capture, compare, and PWM modules, and also PSP. So this is the basic circuit. I will skip because this is only the explanation of the circuit. So this is the basic circuit. What we have here, maybe 20 megahertz, 16 megahertz, 8 megahertz, and also 22 or 33 picofarad capacitor. So the first pin is connected to the 10 kilo ohm to the 5 volts, and also the 11 pin 11 and also pin 32 is also connected to the 5 volt, and the others pin 31, 12 is connected to the ground. And for the example, you can use the LED here connected to the 21 pin 21. Okay, just with 10 kilo ohm to limit it, the current, so the LED can go wrong. Okay, you have to limit your current going into this LED. Okay, this is the explanation. I have explained the basic circuits. Okay, you can use the crystal as from 4 megahertz to the 40 megahertz. So don't worry. So this is the 5 I/O, just I mentioned before. I will skip this. This is the group of each of the port. This is port A, the second pin and the 7th pin, port E. This is all the port B, and this is the port C is from left side and right side. Also the port D is in the right side and the left side. So this is the serial pin is 25 and 26. Okay, serial pins RC7, RC6, RXTX, and this is the I2C communication from the pin number 23 and pin number 18. For the STK, this is STE or STE. So what about the interrupt facility? PIC16F87A has a total 8 interrupt. Okay, 8 interrupt, just like this. 8 interrupt sources. Interrupt sources is some event which generate interrupt. The source could be a timer, like interrupts are generated after every 1 second, or it could be also be pin state change event, like if pin state is changed, then interrupt will be generated. Maybe from the here port B state change or external interrupt and so on. Okay, let's talk about the how to program the PIC16F87x. So this is the illustration of microcontroller programming. First, this is the pin format and also the hex format that you can upload it to the microcontroller. Execute code in binary and hexadecimal format. Okay, this is the first thing you have to remember. The question is, how do we have this kind of format? So you can write your program in assembly language and then compile using the software from the microchip maybe, and then the compile result can upload it into the CPU using the special device. Uh, I will show you the example of PIC device to upload your program into the microcontroller. So maybe you can use assembly language, maybe you can use C programming language. Yeah. If you have experience in C programming language, I suggest you start with the C programming language, not with assembly language. Assembly language is very unique and it's challenging. Okay, my first lesson book is according to the 8951 microcontroller is using the assembly language. Okay, only assembly language, not C, not the others. But it's unique, it's challenging. But in this lecture we will use the C programming language. Okay, I will not give you more headaches. Okay, so whether you use assembly language or the C programming language, you should compile the program. So we have binary or hexadecimal format, which is we should upload it to the microcontroller itself. So this is the C compiler program hex. We have to use the programmer to upload to the microcontroller, and the microcontroller can work in real environment, maybe robotic application and so on. So this is the illustration from the program written in C. This is the compile program, and this is the executable code of the program in hex code that we should upload to the microcontroller using special device. This is the advantage of the C language. I will skip this. Okay, this top 3 PICC compiler, my version. Okay, my version. The first one is okay. The first one is sure MPLAB X integrated development environment. So this is the official compiler program from microchip itself. The others is from the microe.com. MicroC Pro for PIC you can download and free for limited size of program. You can compile for free but limited size of program. You can buy the license whether it's a soft license or hardware license using the USB. The other is CCS compiler. Okay, it's popular now. The micro CCS compiler is popular. So this is the illustration of our micro C Pro. This is the main program example, just for example. And what is this? This is the PIC Lab. It's our simulator. We will use this simulator to learn programming the PIC16F87 microcontroller applications. Okay, thank you very much. That's is the special microcontroller from microchip PIC60F877 discussion. Yeah, if you have any question, you can write in the comment, and inshallah I will answer and we will discuss about your questions. Okay, thank you very much, and we will see you in the third episode we talk about the reset GPIO and so on. Thank you very much. Alhamdulillah. Assalamualaikum warahmatullahi wabarakatuh.